this through this lecture, this is the lecture on emerging construction systems for mass housing, and through this lecture, I will be uh, telling you about the innovative construction systems which are being practiced world over. They are time tested, proven elsewhere, and we are trying to promote and spread awareness, also educate our professionals on these emerging construction systems. Before I get into these systems, let me just tell you that India is fast urbanizing. The natural question comes to mind that why we require these emerging construction systems. So, as you can see in this slide through this graph, that India is fast urbanizing, and by 2000. Uh, 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 One census we were 290, then 2011 the latest census, 380 million people live in urban areas, and by 2050 815 million people will live in urban areas, which is 50% of our population. 815 million means 81.5 crore people will live in urban areas, and to cater to this growing population we have to build 600 to 800 million square meter urban space every year till 2030. And 600 to 800 million square meter urban space means a new Chicago city every year we have to build. So to keep pace with this fast urbanization or rapid urbanization, we have to build pretty fast. And all of you know that the conventional construction systems are not as fast, and most of the projects take a lot of time to get completed. So we have to introduce faster construction systems or expedite the construction time, or reduce the construction time and expedite the project completion time. And for that, we need to introduce these innovative construction systems. And at the same time, when we are trying to, introduce these fast track construction systems, we need to remember that without sacrificing structural and functional performance. So in no way the technologies which I will be talking about, or these innovative construction systems, in no way they are inferior than your conventional construction system. Rather, they are better as far as structural performance, functional performance is concerned, sustainability aspects are concerned, resource efficiency is concerned. Also, what you see on the right hand side of this slide, India, all of you know, we are right now $3 trillion economy, and we are aspiring to become $10 trillion economy by 2030 or 50. And construction sector is going to play the most important role if we want to take our country to $10 trillion economy. And all of you know, it is coming in newspapers that India is one of the fastest growing economy in the world, and we are at the moment we are fifth largest economy of the world, and our sector is going to play very important role. So we need to introduce, if we want to keep pace with the fastest growing economy, and want to keep pace with this rapid urbanization, we need to introduce innovative construction systems which are receptive, innovative, and productive, so as to foster sustainable growth. All of you know that nowadays we are talking about net positive, we are talking about zero emissions by 2070, we are talking about sustainability. And so in order to foster sustainable growth, we need to introduce, we need to think out of box. We need to think of technologies, materials which are other than your conventional building materials or conventional construction systems, which are cast in situ RCC frame construction. Also, this is something you can see that always remember, there is a 3S mantra, which is which you need to think of: skill, scale, and speed. So by 2047, when we celebrate 100 years of our independence, we need to have a new young India, and to take our country, to make our country as developed country. Always, we have to introduce new sets of skills. So construction sector, we need to have another set of technologies, new sets of skill, and we need to introduce speed. So skill, speed is very important at scale. The kind of skills we have nowhere in the world, those kind of skills can be thought of. I think I have a slide on Pradhan Mantri Awas Yojana. 120 to 1.2 2 crore houses have been sanctioned by Ministry of Housing and Urban Affairs. That was the demand by the states. That number of houses can never be thought of by anyone in the world. And if I have to tell you that the biggest urban renewal schemes are being run by our country, biggest urban renewal schemes, whether it is Pradhan Mantri Awas Yojana, Smart City Mission, Swachh Bharat Mission, and other schemes. And so scale is also very important. So any new technology, when we talk about scale, need to be kept into mind. We have to upscale the technology. We have to mainstream this. So always remember this 3S mantra: skill, scale, and speed. And as conventional civil engineers and architects, we are most of the time we are thinking cost per square meter, but in times to come, speed is going to play the most prominent role when we decide about the materials as well as about the construction systems. Speed, in how much time we are going to finish the project, whether it will take 18 months or 12 months or 6 months. And on your dashboards we have films. So there are examples right now in our country where buildings have been finished within a span of 6 months. And we have two lectures on last day where they will be sharing with you that in 45 days, 60 days, they have completed the entire apartment, 36 apartments. Similarly, in our own project under Pradhan Mantri Awas Yojana, we have completed few projects in a record time, and one floor in one 13-story building in a time of 1 month we completed. So these things, earlier we used to think of this, but right now the technology is available in our country, and it has already amply demonstrated in our country that these technologies really reduce the construction time greatly. So this is that slide which I was talking about, because the BMTPC, this entire effort of NAVARITIH is under Ministry of Housing and Urban Affairs, and this quest for new technologies or innovative technology started with Global Housing Technology Challenge, which I will also be discussing. That GHTC, or this search for innovative technology, started under Pradhan Mantri Awas Yojana. Under Pradhan Mantri Awas Yojana, we are running a submission called Technology Submission, and through that submission we organized a Global Housing Technology Challenge, and through that challenge we shortlisted these new technologies, and now we are promoting these technologies across the country. And just to give you figures of Pradhan Mantri Awas Yojana, the validated demand given by these states in 2015 was 1.12 crore houses. Was the urban housing shortage in EWS sector, economically weaker section, or poorest of the poor. And right now we have sanctioned 1.23 crore houses, out of which already 72.83 lakh houses have already been completed and handed over to beneficiaries, and around 1 crore houses have already been grounded. And out of these houses, 16 lakh houses are being constructed with these new technologies, which I will be discussing with you. And when we talk about these technologies, sometimes questions are being asked, are we reducing the use of cement or steel? We are using cement and steel, but we are using them efficiently. Okay. And Pradhan Mantri Awas Yojana has also been helpful in generating the employment, and you can see through this slide, that so many mandates, so many jobs have been created. 86 or 2.77 crore jobs have been created through Pradhan Mantri Awas Yojana. And the bottommost portion of this slide shows you the cement consumption and steel consumption through this Pradhan Mantri Awas Yojana. So this is just for your record that so many houses are being constructed under Pradhan Mantri Awas Yojana. And now let me straight come to the lecture. So when we talk about construction system, a natural question comes to everybody's mind, that what is construction system? So there are two things, dear friends. One is material. So we are using material which is cement, concrete, or building elements which is brick, brick blocks, or a panel. But construction system is the system which helps in transferring the load of the building to the foundation. So structural system, that is called construction system. So we are trying to replace the conventional construction system by innovative construction system. So what do we have? What is business as usual approach, or what are the construction systems which are prevalent world over? One is all of you are aware of RCC framed structure. Means we make beam column RCC frame, which is cast in situ normally. So we have a formwork, then we insert a reinforcement cage, then we do the concreting, remove the formwork. So that's how a network of beam and column is cast. Then we cast a slab, and then we fill the walls with the infill wall. So this is the most prevalent system world over, which is called RCC frame construction system. Okay, and so the question is, can we replace the system by any other construction system? So that is the whole premise of this lecture, or these innovative construction systems. So I hope you understood that we are not trying to tell you that replace this material, but replace the construction system. And construction system is like, it's the skeleton, like a human skeleton. Similarly, the construction system is skeleton or structural system of your building. The other construction system is load bearing. All of you are aware of that when the walls, load bearing walls are constructed along with the cast in situ slab. So that is, for isolated buildings or isolated structures or isolated houses, or houses up to 2 to 3 stories. Normally, this kind of load bearing wall system is being constructed, and we are trying to replace these two. So what about, instead of casting these beam and columns at site, we cast them somewhere else, like precast. All of you are aware of precast systems, all of you. So instead of casting these beam column slabs at the site through formwork, putting the cage and all, if we cast them somewhere else off site, and then transport them to the site and assemble them, and then there are a whole lot of advantages of these things, and these kind of things are happening in our country. There are a number of technology providers, contractors, agencies who are into this. And also the good news is that Government of India, for the first time, proactively, not only promoting but implementing these innovative systems in their own projects, including CPWD. So I think through this slide I have made it clear that we are trying to replace existing cast in situ frame construction by innovative construction system, which is basically a load carrying structural system of your building. Also, most of you know about this, but let me tell you that there is too much dependency on cement, aggregate, and water. All of you know water is scarce. Then fine aggregate, sand. Some of these states, they have already banned the use of sand. Tamil Nadu, if you go, you don't get sand there. Instead of that, you have to use quarry dust and all. And similarly, water. So we don't say that don't use cement, aggregate, steel, but use them efficiently. And all of us know that when we do cast in situ construction, how the water is being used, how aggregates, how the mix is being done. All of you know. So there might be wastage of these materials. So once we do the construction, or once we manufacture the material components in the factory, you can optimally use these material. So I don't say that don't use these material.
मीटिंग चल रही है, ठीक है। हाँ, इसमें फोन में आवाज नहीं आ रहा, फोन आता है तो आवाज आता है।
Please mute yourself, Mr. Darsharat. Please mute yourself. What I'm trying to tell you that use these materials, of this cement, aggregate, the sand. Nobody knew that sand will become so precious. So use these material optimally. Okay, and then during COVID time also, it was seen that there was mass exodus of workers, laborers from cities to their own their native villages and all. Can we have technologies? Can we have and the all construction works came to standstill during COVID time. So that also need to be seen. Can we mechanize? Can we industrialize the entire process of construction system? Mechanization, industrialization of construction system, construction industry is also need of the hour, and for that we require these kind of system. So basic premise is that instead of doing everything at the site, if 50%, 60% or entire thing we do in under control condition in a casting yard or in a factory, it is sometimes called assembly line production also. Okay, like a car or automobile industry, you might have seen. So can't we have an assembly line production in construction sector? You bring column, bring beam, bring slab, erect them, and your building is ready. Okay, and the third point is also very important as engineers and architects. When I studied, 40 years back, 40 years back. So that time green buildings were never talked about, sustainability we never heard of. But now, as engineers, as professionals, as project directors and all, it's our responsibility that whatever project we undertake or whatever materials or whatever construction system we use, it has to be sustainable. There should be minimum wastage, and the project should be somehow green, energy efficient, eco-friendliness. So all these things need to be talked about, and these innovative construction systems help in some of these things. Okay, and as I told you earlier, also speed is one of the most important criteria if we want to, have our country, by 2047 as a developed country. We want to build new young India, and the kind of urbanization we have to introduce these fast track construction system in the construction industry. Also, you can see this already I covered that primarily these systems which I'm talking about are slow track construction system. All of you know that most of the projects, for the want of sometimes material, for the want of scarcity of labor, because of inclement weather, most of the projects struggle with time overrun and cost overrun. Once the project is delayed, the cost is also escalated. So these are the cast in situ construction system, are slow track construction system, and we need to introduce this fast track construction system. Also, this is just a slide to green. Every time we are talking about green building, sustainability, and all. So I thought I will put a slide for all of you to make you understand that what is green and why, how do we incorporate green aspects when we talk about new technologies or when we talk about a project. So first and foremost thing is resource efficiency. In no way we say that cement, you use steel, you use all these materials, but use them efficiently. And how can you use them efficiently once you produce or manufacture these components under controlled conditions? So resource efficiency, or make use of some waste material like fly ash, slag. The projects which I will be discussing with you again, in when we are using precast concrete, we are using fly ash, or we are using sometimes GGBS and other supplementary cementitious material, which not only enhance the durability of concrete but enhance the strength and other things also. Energy efficiency is also very important. So we need to use energy efficient materials, energy efficient construction system, and then eco-friendliness. The materials, the technologies we should use which have less greenhouse gas emission, which can be recycled. I will show you the life cycle cost also. And then health is also very important, health of the occupants. And how many times we always take it for granted that the health of the occupants in the building, when we construct a building with business as usual approach or with this conventional materials and all, the inside air quality is good, but which is not the case. The kind of paints, varnishes, the kind of pesticides, the kind of detergents and other things we use, the inside air quality is sometimes uh, more poisonous or more dangerous than the outside air quality. So, uh, health of the occupant is also very important. So always think whenever you are thinking of Mr. Darshan, all the time I'm hearing your voice. Please mute. Dilip, why don't you mute Mr. Dashrath? Okay, friends, think whenever you think of a project, think of resource efficiency. What kind of waste material you are using? Is that waste material in terms of fly ash, slag, or any other material? Then, in what way your project, if compared with conventional materials, in what way you are saving on energy? So there is a concept of embodied energy. The materials which you are using, what kind of embodied energy they have, as compared to your conventional materials. Then eco-friendliness, less greenhouse gas emission, less noise and air pollution, and the health of the occupants. This is again a slide, very interesting slide to show you that buildings consume 40% of precious energy source, 25% of potable water. All of us know that when we construct, in construction for curing, we require potable water, or drinking water. So 25% of fresh water is being consumed by buildings during construction, and 40% of natural resources. All of you know cement, steel, all of these are based on natural resources, cement and limestone, that is on iron ore. So buildings consume major percentage of these precious resources, whether it is energy, water, or natural resources. And if you look at the bottommost portion, at the same time, they consume so much of resources, precious resources. At the same time, building activities contribute 50% to air pollution, 42% of greenhouse gas emission, 50% of water pollution, and 48% of solid waste. Okay, and all of you know that India is signatory to Paris Agreement, then COP 21, COP 26, and as signatory to this agreement's climate mitigation strategies, we need to reduce, or we by 2070, India is committed to have zero emissions. And uh, why I'm telling you this, because construction sector is one of the biggest contributor to these greenhouse gas emissions. As you can see here, 42%. So we need to introduce technologies, we need to introduce materials which can help reduce air pollution, greenhouse gas emission, less waste generation, and things like that. And that is why we need to resort, or we need to introduce these innovative construction systems in the construction sector. Okay, and this is the data from the Energy Research Institute and RIHA. Also, this already I told you, now this is an older slide, but now by 2017, 70, India is committed to have zero emission. And there was a report from UN which says that if we continue to have business as usual, remember I told you business as usual approach means if we continue to use load bearing brick construction, or cast in situ frame construction, our greenhouse gas emission through construction sector will get doubled. Okay, so we need to reduce that. So, in essence, if I have to tell you that why do we require these innovative emerging, so you can call them new technologies, you can call them emerging or innovative or sustainable technologies. Why do we require? First and foremost thing is the speed. As I told you, that uh, in addition to cost, speed is going to play a very important role in deciding the construction system, material, and your project attributes. Okay, so speed. Please keep in mind that the time completion. All of us know about Parliament building, and that Parliament building, beforehand it was decided it has to be completed within this span. Similarly, for projects, because this is very important if we want to have resource efficiency, if we want to save on cost and other things. Because if you complete the project within a stipulated time, you save on a lot of things, and it has direct impact on environment, energy, and other things. Okay, so speed is very important. Quality cannot be compromised, and all of you will agree with me. Doing construction at the site or off site, there is a whole lot of difference. Once you industrialize or you mechanize the construction, activities, you will have better control on quality. You can assure the good quality, and you get a good quality product. And again, quality is again related with all these things I'm talking about, with greenhouse gas emission, with maintenance, with cost, with efficiency. Okay, safety also, friends, it's very important. India is a country where we have multi-natural hazards. We have earthquakes, we have cyclones, we have landslides, we have excessive rains. So all these structures we build need to be hazard resistant. Okay, so hazard resistant, earthquake we have been talking about. So all these new technologies we talk about, they are disaster resilient. Okay, they help in disaster resistant construction. And sustainability, as I told you, that energy efficiency, eco-friendliness, less greenhouse gas emission, waste minimization, use of waste material, or use of waste into building material, that is also required. So sustainability is also very important. And these new technologies can help build sustainable structure. And the fifth point which you see here is life cycle cost. And And let me just dwell upon this life cycle cost. All of you, when we talk about cost in a project, we always see cost per square meter. So that is nothing but a initial cost of construction. And most of the time, that only comes to our mind if a building is constructed, or if you present a project, everyone will ask that what is the cost. But that is the initial cost. There are two more costs added to this. One is operating cost of a building, which we often, as a project manager or as a project director or as a professional architect or engineer associated with the project, we are concerned that we have to give to the client cost per square meter. But what about the operating cost? The building lasts for 70 to 80 years, 60 to 70 years. So during that lifespan of a building, the operating cost of a building, the maintenance cost, that we don't take into this cost. And then once the service life of the building is over, how many of us have ever thought that once the building service life is over, how that building is going to be disposed in the how it will be disposed. So that is called disposal cost. So life cycle cost is a summation of your cost, initial cost of construction plus operating cost of a building plus disposal cost of a building. Once the service life of building is over, how you are going to dispose that building, how the building components will be dismantled, and can they be reused, recycled, or they will just be left just like demolition waste. So nowadays the concept of life cycle cost has come, and that is why I think we have engineers from NBCC also. So in GFR, general finance rules, we have introduced the chapter on life cycle costs. So projects of bigger size, whenever we are thinking of a project of bigger size, we need to think of life cycle cost also. So it's not only the cost of construction, but it is the life cycle cost. And nowadays there are models available, so you can estimate that life cycle cost. And therefore the point I want to stress upon here is that any material, any technology you use, think of not only cost, but think of speed, think of life cycle cost as well. And in times to come, this will also be the deciding or important factor for the project. Also, whenever we are talking about these new technologies, our architects and other friends, they keep asking, sir, these are thinner elements, these technologies, how do they fare when we talk about functional parameters like fire, fire resistance, or fire rating, then thermal, and then sound acoustics. So let me tell you that all these new technologies, because in the beginning I told you that these technologies are time tested and proven, and so the thermal efficiency, sound acoustics, and fire rating of these technologies are as good as your conventional system. And let me also tell you that if you are doing a construction in Indian context, so all these new technologies has to comply with the existing Indian standards. Okay, so whenever we undertake a construction project, like for earthquakes, for concrete, for national building code, or for anything, we have codes. So all these new technologies has to comply with the existing Indian standards. So if we say that fire rating in a residential for a wall, fire rating of 2 hours is required, or 1.5 hours is required, so these technologies need to comply with that, and they comply with all these things. So most of the time it is being asked from me that, sir, what about fire rating? And also, if fire rating is not as per the existing national building code or the other relevant code, the technology cannot be used. So most of these technologies, they comply with that. Okay, and just by introducing these new technologies, again, this is the data from the Energy Research Institute. We can reduce considerable energy, 30 to 50%. We can 40% reduction in water use, 35% reduction in greenhouse gas emission, and up to 75% waste can be reduced. You all know that when we in a typical project, a lot of wastage generated, which is nowadays C&D waste is being talked about. Okay, construction demolition waste, which has become a nuisance, and all urban local bodies, they are thinking of ways and means to make use of that construction and demolition waste. So in times to come, the projects, in the whatever projects you do, you have to minimize that waste as well. Okay, so this is what this is why we require these new technologies. Okay, so this is the background. This is again a very interesting slide, and again, this is taken from one of my friend who will be delivering a lecture in this course itself on the last day. So I have taken the slide from his presentation, and you can see whatever so far I told you. I'm talking about what I'm talking about. I'm talking about this. So. I will just explain you this, but what we most of the time we do our construction like this, and we want to take a paradigm shift or a quantum leap from this label to these labels. Okay, I will just explain you. So the idea is to take our country from this level 0 to level 4. So these labels show the levels of construction technology in our country. So level 0 is, all of us know about it. So what we do, we take, collect the material, basic materials at the site, and then we call the labor contractor, we erect the formwork, we erect the reinforcement, then we do the concreting, whatever it is, do the curing, plaster, and all those things. So that is label 0, and this is the most prevalent label in our country. Then label 1 is where, bus stands, railway platforms, or industrial buildings, where we have trusses, steel trusses or steel columns. They are made or manufactured in the factory, primarily steel structures or other things. And then you all know industrial structures, how they are being constructed nowadays. So those trusses are being brought to the site and assembled at the site, and you make that structure. So that is label 1. Label 2 is where you make these building components. So the label 0, you collect the material at the site, and here all building components, structural, non-structural, whether it is beam, whether it is column, whether it is wall, whether it is a staircase, whether it is sunshade, whether it is any other element of your building, shelf. So all these things are made in the factory or in the casting yard, and then you transport them to the site and assemble them at the site. So these are the building components: wall, beam, column, slab. So they are made in the factory. So it is a prefabricated series of prefabricated elements which are manufactured under control condition in a casting yard. Casting yard can be just near to your site, or it can be in the factory. You all, let me just give you the example of metro. All of you know how metro is being constructed. So they have a casting yard, like for example in Delhi, at few places they have a casting yard where those girders, long girders, even bridges nowadays, how they are being cast, all of you know. So piers, they do cast in situ, and then over that they put the girders which are cast somewhere else, and they are brought to the site and then assembled at the site. So similar thing you can do for housing as well. And the moment you do this, whatever I just explained you in my earlier slides, it makes sense that you save on material, you save on environment, you save on cost, you also reduce the construction time and other things. Then level 3 is another notch above. You can see here. So instead of making 2D or linear planar elements, you make the entire module. Okay, so the entire module is made in the factory or in the casting yard, and then they are being put one over the other like Lego blocks. In fact, Honorable Prime Minister, when he was, laying foundation for our lighthouse projects, so that time he used this word that we have a technology where you make the entire module in the factory and then put them one over the other like Lego blocks. All of you remember your kids, how they play with building blocks. So using those building blocks, you can create the structure of your choice. So you put one block over the other to create a multi-storied building or multi-storied, structure. Same thing is available in the construction sector or as a construction technology. And so you make the module. just think of toilet. What is the use of making four walls and then putting a slab? Instead of that, the entire pod element, it is called, the entire toilet pod, you can construct, or you can manufacture in the factory, and then just bring it and just put it at a desired location. So that is the kind of thing we are talking about. So that is level 3. And again, you might be thinking that how it is possible. The good news is that right now in our country, there are a number of agencies who are into these level 2, level 3, level 4. And in fact, under Pradhan Mantri Awas Yojana, we are doing these projects. Under Pradhan Mantri Awas Yojana for EWS housing, we are implementing this kind of technology. And the persons who are implementing these technologies, they will be delivering a lecture. So this is called 3D volumetric construction. So as per your project size, as per your project requirement, you create a casting yard and do the module. Casting of module is done, and then these modules are put one over the other with proper jointing. And also, the joints and connections are as good as your monolithic joints. Okay, so they are called emulative joints, and there will be lecture on precast concrete construction as well. And level 4 is another notch above level 3. So here we are just making the module of concrete, but in level 4 we do the finishes as well. So we do the plaster or color wash. Then we put the services also, window frame, door frame. You can put the door shutters as well. You can put the glass if you want, or you can put the tiles, whatever you like. So this is a pre-finished house. So that is level 4. So fully finished or pre-finished house you can have. And again, as I told you, that there are agencies in our country, and there is one agency called Magicrete, and their CEO will be delivering a lecture in this course. And in Ranchi, we are doing a project where 70% of the work of a module is done in a casting yard, and all you have to do is you have to just put it there and start using it. And this technology is also called as plug and play homes. So let me just tell you, plug and play homes, plug and play devices are like your USB drive. USB drive is a plug and play device. So what does that mean? That means that you insert your USB drive into a USB or into a computer or into a TV, and it starts playing the film or whatever presentation you have. In a similar fashion, you have plug and play homes. So the entire house or entire module is made in the factory, pre-finished, and then just you bring it, transport it to the site, put it with the foundation, and just connect it with the services and start using it. So that is called plug and play homes. And there is another lecture last day again, where they are trying to you can online order your house. Okay, so depending upon your size and dimensions, you can online your order house and they will deliver. So they are trying. So the construction sector is thinking on that way. Okay, and the good news, as I have been telling you, is that these all labels exist now in our country. It is not something which I'm talking new. Already, there are agencies, there are technology providers, there are contractors, there are consultants available in our country who are already into this. That is number one. Secondly, in a government under Pradhan Mantri Awas Yojana, we are already using these technologies. We are using these technologies for demonstration housing projects, for lighthouse projects, and under Pradhan Mantri Awas Yojana, few states they are already using these technologies. So it's not that something which we have brought from abroad and trying to teach you. Already these know-how, technology, and agencies are available to implement these projects, and government itself is implementing these technologies in their projects for EWS housing. So I think from this slide, this is clear to you that what we are trying to, teach you, or what we are trying to bring in the construction sector, and we often call it to bring a quantum leap or a paradigm shift from level 0 to level 3 and level 4. Okay, and some of you might be knowing that there are, like, for example, if I give you the example of DDA, more than 60,000 houses in Delhi itself are being constructed with level 2 technologies, where, in a casting yard, building components, you all know bridges and metros, the infrastructure, big infrastructure projects, we are using precast technologies, and that precast can be used gainfully in the residential sector as well. And a lot of houses are being made with this level 2 and these level 3 and level 4 also. There is another very interesting terminology which is knocking at Indian construction sector is DFMA. Okay, all of you know, when we talk about construction, what comes to our mind? We think of contractor. Okay, a contractor will come and he will construct. We will give him material, or we will ask him to bring the material, and then he will do the construction. He will bring the forward. Nowadays, agencies are available which are called DFMA agency, and DFMA stands for Design for Manufacture and Assembly. So, as per your project requirements, as per your project site, these agencies will, entirely conceive your project, set up a plant for you, set up plant and machinery, then manufacture those building components there, as and assemble your building, and then go away with the plant, plant and other things. So they are called specialized DFMA agencies. So the entire project, like, will be conceived by them, including plant, machinery, and everything. And these kind of agencies now, so in times to come, instead of contractor, you will look for this DFMA agency if you want to use these innovative technologies. So they will set up a plant near your site, or if your site is near to the factory, then you can always take the material from the factory. Otherwise, at a casting yard, they will set up plant and machinery, and once the project is over, they will take away that plant. So I thought I will introduce you this term. So replacing the contractor word by DFMA, design for manufacture, design for assembly. Okay, and then this is also very interesting. Whatever I so far told you or taught you, let's replace construction by manufacturing of building. So the moment you understand the difference between construction and manufacturing of building, you will understand what am I talking about. Okay, so the moment I say manufacturing of building, that means you are doing something under controlled condition in a factory-like environment. I use the word assembly line production. So make building components, make the building in a under control condition in the casting yard. So instead of constructing a building, manufacture the building. Okay, and there is another word for this is PPVC, prefabricated pre-finished volumetric construction. As I told you, nowadays, there are companies who are making pod elements, so there is no need to make separate bath, separate toilet, or you can just buy a pod element, and there are pre-finished prefabricated volumetric construction, it is called. So it's essentially a entire room with finishes and all, and you can there are agencies who manufacture those kind of things. So I thought I will just introduce these words also to you: manufacturing of buildings, prefabricated, pre-finished, PVC, and DFMA thing. Okay, and another thing is building information modeling. Some of the participants in earlier lectures, they said that we should also have a lecture on BIM, but in times to come, when we talk about these new technologies, we have to introduce BIM modeling also into the construction sector. BIM is nothing but creating a twin model of your building in the computer. So virtual model is being created in a computer. So there is no need to go to the site. From the you can entirely control the site activities through the building information modeling. And most of the countries, they have made it mandatory to have a BIM model. And in near future in India also, the BIM model will become necessary for us. Like we have AutoCAD drawings and all. Similarly, in times to come, we need to create a BIM model. Okay, so I thought I will just introduce these terms also to you. Now look at this. This is the first 3D printed house. And again, this is a older slide. Now we have number of agencies, and now number of houses and other things are being printed. When I'm talking to you, there is one agency from IIT Madras. They have printed few buildings for Ministry of Defense. Also, some barracks and all are being printed with this. So 3D printing, and nobody thought that we can print the building as well. And this was the first 3D printed house at Kanchipuram by L&T, and I was also associated with this. And this project was inaugurated. This building, the first 3D printed building, was inaugurated, I think, in 2021 by our Honorable Finance Minister, and I was also present during the event. So this two-story printed house in our country by our own agency L&T has been printed, and there are several technology providers and agencies who are into this. As I told you, there is one startup. They have just bagged a project for printing barracks for Ministry of Defense. Near Chandigarh. So the 3D printing, again, nobody thought that we can print a house. So like we do the printing, we just feed command to our computer and we get the print. Similarly, here the entire thing is industrialized, and uh, you have to just give a command and your house is being printed with the help of robots and other complicated machinery. And here, the construction ink is nothing but a specialized concrete. Okay, so you have robots and you have a construction ink which is concrete, and you can print the entire house. So this was the background of the new technologies and the terms associated with them, and what do we require, why do we require these technologies. And now let me just give you about these, briefly introduce these technologies. And as I told you, that all these categories, we have categorized these technologies like this, so it is not sacrosanct. It is just for the better understanding and better comprehension. We have given the names, and these each category will be explained to you in detail from tomorrow onwards. But today I will briefly introduce all of them to you. So I've given a name: engineered formwork system. So this will be explained to you day after. Then stay in place formwork system, sandwich panel systems, cold form or light gauge steel structural system, then steel structural system, and then precast concrete construction system. And precast concrete construction system, that category has been divided into two. One is 3D volumetric, where the entire module, as I explained you, or otherwise, you make 2D or linear elements and then assemble them at site. So as you can see, 2, 3, 4, 5, 6, 7. So each day, one category will be explained to you. Okay, and I will now briefly introduce you these categories to you. But before that, let me also tell you that again, I have put 2 or 3 slides for you, that whenever we deliver these lecture, whole lot of questions are being asked. Sir, are we compromising on quality? What about time? What about cost of construction? So let me tell you, any new technologies, we have in fact created a framework, a technical framework also, to evaluate these new technologies as compared to conventional. So no, at no point of time, or at nowhere, these innovative technologies are inferior than conventional as far as quality is concerned, time and cost is concerned. So let me just explain to you. Quality means safety of structure, with not only with respect to or with regard to your live loads, but with regard to natural natural hazard forces like earthquake force, snow load, or cyclone, on other forces. Okay, so any new technology we think of or we talk about, we need to ensure safety of structure. Okay, not only with respect to dead load, live loads, but with respect to other natural hazards like earthquake, cyclone, and whatever load may be. Then, as I told you earlier, also functional performance. So performance of structure, not only this entire structure, but its components as well, with regard to thermal, with regard to fire, with regard to acoustics, with regard to water tightness. Okay, so when we introduced these technologies in the construction sector, we did look at all these things before introducing these technologies in the sector. Then efficiency, because most of these technologies, as you know, are you know, factory based, so you have to, you know, give attention to the joints. Okay, so efficiency of joints, are they monolithic, are they watertight, that also is to be ensured. So performance in terms of efficiency of joinery system, acoustics, dam proofness, water tightness, thermal, with regard to thermal, and also fire rating. Okay, so all these things are very important, and none of these parameters can be compromised when we talk about these new technologies. Also, the natural question comes to our mind that what is the life? If we are using this pre-sandwich panel system, or we are using a steel structural system, or we are using precast, what is the life? So all of us know that the typical life of a structure is 60 to 70 years, and the life of structure using these new technologies cannot be less than the life of conventional structure. Otherwise, these technologies will not be accepted. So durability, there have been studies on these technologies, the durability of these structures with regard to component wise and with regard to joints and all. Okay, whenever these technologies are being assessed or being evaluated, they are evaluated based on these technical framework. Okay, then this already I explained you that traditional construction, as I told you, that one is quality, then another is time. So when we talk about time or speed, traditional construction, all of you know, is a slow track construction and not amenable for mass housing projects. And because of undue time taken, most of the projects, all of you know, are caught with time overrun and cost overrun. And once your project is into time and cost overrun, there are a lot of overheads are added, there are a whole lot of wastage, not only or in terms of human resources, but in terms of material as well. So speed is the call of the day, or need of the hour, speed of construction. Okay. um, Also, it has become essential to go in for faster construction in order to meet the heavy demand and in order to cut wastages and overhead. So you all agree with me, and speed is one of the important criteria for to decide the technology to be used. Okay, and this is just a slide to show you that the most common question which comes to our minds are, what is the cost? So let's say the cost can also be reduced considerably once the technology is mainstream or something. You can see these economies of scale. Okay, so economies of scale plays an important role while deciding the costs. Let me explain you economies of scale. Because most of these technologies are based on factory setup. So let me give you example of suppose you set up a plant for manufacturing, or for one shirt or 100 shirts. Okay, so if you produce one shirt or if you produce 100 shirts, the factory setup is same. So if you make 100 shirts, the cost will be equally divided into 100, otherwise it is loaded on one shirt. That is called economies of scale. So similarly, if you have a project size is bigger, then the cost will be lesser than your the conventional cost of construction. That is called economies of scale. So whether you are doing precast concrete construction or you are doing steel structure or anything, economies of scale plays very important. So this is for the initial stage. Once the technology is mainstream, once we have enough plants across the country, then economies of scale will also go away, and you can have as good, as robust house in a similar cost as your conventional cost. And also, because we are talking about climate change, we are talking about global warming, we are talking about greenhouse gas emission, we are talking about eco-friendliness, we are talking about green buildings, we are talking about resource efficiency, climate responsive design. So cost is not the only factor. It is environment, it is time, it is quality. So cost effectiveness is more important, more critical than the cost per square meter. Okay, and as I told you earlier also, life cycle cost. As as professionals, it's our responsibility that whatever construction we are doing or whatever material or technology we are suggesting, what impact that technology or material has on the environment. How much is the embodied energy? What is the greenhouse gas emission? So those things are to be thought of. Those things are also to be considered when we do a project or when we decide the material and all. Okay, so this is about the background, and this is just to sum up this that end user benefits through these technologies: safe and disaster resilient house, better quality of construction, low maintenance, speedy construction resulting in early occupancy, cost effective and environment friendly, which is also very important, and better functional performance of the buildings. Okay, so with this was the background. We will take a break of say, let's say 5 minutes, and then I will introduce to you all these 6 categories. Okay, so let's break for 5 minutes. Seven. Now let me introduce these technologies to you. Yeah. So as I told you that for the sake of clarity, we have categorized, rather I have categorized these technologies into these broad categories. So this is just the name given by us, and then this name is still going. So engineered formwork system, stay in place formwork system, sandwich panel or drywall construction, light gauge or cold form steel structure system, and precast concrete construction system. And those 54 technologies which we have shortlisted through Global Housing Technology Challenge, they are also categorized into these 6 broad categories. Okay, so what we have done is steel and this we have clubbed together, and this we have done in 2 categories. Okay, so I will just explain you these one by one through pictures, and anyway from tomorrow onwards you will have detailed 3-hour lecture on each of these categories. And the blue book which I was talking about, that is also written in such a fashion that each category is explained in one chapter to you. So let's first talk about formwork systems. Okay, and we have given it a name, engineered formwork system. All of you being civil engineers, being professionals, being architects, know about formwork system, and so there is no need for me to explain you that what is formwork. So formwork is a temporary or permanent mold which can be of timber, which can be of steel, which can be of plywood, which can be of wooden plank. So a whole lot of formwork systems are being used in the country, and this formwork is the conventional or traditional formwork. Nowadays, this formwork can be replaced by aluminum. You might have heard of aluminum formwork system, or a formwork which is made under controlled conditions in the factory. So there are manufacturing plants where you make the customized means tailor-made formwork suiting to your project requirement. So that is called engineered formwork system. Okay, so again, then we have another 2 kinds of formwork system which I will explain you again when we talk about that category. So first category is engineered formwork system, and most of you know this system by you know my one. Okay, my one is the technology, or alu form or aluminum formwork. And through this picture I am trying to explain you what is this. This is a conventional construction system where this red thing on a upper left right hand corner you see is this is the formwork, this is the reinforcement, then you put the concrete, remove this formwork, and this formwork is of steel, or it can be plywood, or it can be wooden planks. Okay, what about replacing this entire formwork by this kind of customized formwork system which is made of aluminum, and there is no need to make beam, column and slab separately. Here the entire formwork is manufactured in the factory, then brought to the site, and you do the casting in one single pour, and then remove the formwork the next day, or and then take it to the another floor. So you can understand the advantages. So this is called aluminum formwork. This can be called shear wall system. This is called monolithic concrete construction. There are umpteen number of names to this system, and we call it monolithic concrete construction, shear wall technology, or most of us know it with Maivan, because Maivan was the company from Malaysia. Who introduced this system to the country, and now Maivan, they have stopped manufacturing this formwork there in Malaysia, and they have set up the factory here in our country. And when this technology came to India, there were very few players. Most of the formwork was coming from abroad, but now in India we have more than 50 formwork manufacturers, more than 50 formwork, and this is the most most popular technology in the construction sector, this monolithic concrete construction aluminum formwork. Okay, so I think you understood this, that we are replacing cast in situ formwork, traditional formwork, by this customized formwork. And this formwork, primarily this is of aluminum, but there are composites are also being tried, steel is also being used. The idea is how many repetitions it can have, because this is being customized, being made in the factory. So if it has more repetitions, it will be more viable. uh, However, if it has more repetitions, then you have to have more number of dwelling units. Okay, and then it ensures assembly line construction. So assembly line construction means, when I talk about assembly line, think of industry, think of any industry, or think of any, like automobile industry. So in automobile industry you have an assembly line. Assembly line means you put a part, then again you put a part, and at the end you get the entire car made. So similarly here, you put the foundation, then you put the formwork, then you put the reinforcement, and in a single pour, you do the concreting, then remove the formwork other day, leaving the prop, and take it to the next floor. So there is a cycle of 3 days, and you can get the entire building made within no time. So on this formwork system, Dr. K.M. Soni, who is retired from CPWD as ADG, Additional Director General, he will be delivering a lecture. Then we have got another person from L&T, who is a formwork specialist. He will also be delivering a detailed lecture on this formwork system to all of you. So I just wanted to introduce you this formwork system. So I think you got the basic idea, or the concept, that we are replacing the conventional formwork by customized formwork. And if you go to the any manufacturing plant where these formworks are being, these are customized. So means, customized means as per your requirement, they are being, you have to give the order, and then they will make the formwork. And for this formwork, they are using robotics, high tech technology is being used with high amount of precision. This formwork is being made, and once the project is over, you can always give it back at a salvage value of 30 to 40%. I am being told that there is a salvage value of 30 to 40%, and this formwork is again recycled to create another kind of formwork. So adds to sustainability. Other advantages I can keep on discussing: less number of joints, less maintenance, shear wall kind of construction, better for earthquake. And because it is a shear wall construction, you have thinner walls, and once you have thinner walls, you get larger carpet area for the same built up area. So cost is reduced. Then speed, all of you know, the speed is greatly enhanced by these kind of systems. Okay, and again, let me show you a few more slides so you can see here. Again, this is a slide from one of the PMAY site, as you can see. So what you see here, so for the entire layout, the formwork is first reinforcement is laid, and then the entire formwork is laid. And once the formwork is laid, then you do the concreting, and once you do the concrete, then you can take it to the next floor. So staircase, the sunshades, everything is cast together. So it's a pakka, pure monolithic construction. Okay, and as you can see here, the conventional mode of construction is RCC frame construction with infill walls. So you make beam, column, and then infill walls, and then you put all those things. But here, all walls, floors, slabs, stairs together with door, window openings are cast in situ monolithically using specifically custom designed modular formwork, which is normally made of aluminum. And most important thing is appropriate grade of concrete. Self compacting concrete is being used. I'm not going into detail because there will be 2 lectures on this technology. So you have to use appropriate grade of concrete which gains early strength. It should be self compacting concrete as per design, and it ensures assembly line production. And remember, another thing is this is suited for mass housing. Mass housing means multiple units of repetitive type, when a similar design is repeated several times, so that is called mass housing. But now this technology is very popular or widely used across the country. So even for 50 houses, this is more economical than your conventional construction. Earlier, you have to have a certain economies of scale, but now the technology is mainstream and being used. So even for isolated few number of houses, this technology is becoming viable. Okay, another picture you can see, and another important thing here for all these technologies which I am talking to you, foundation is conventional. Okay, foundation conventional means it can be isolated footing, it can be continuous footing, it can be pile foundation, it can be raft. So why we are keeping footing or conventional foundation? Because India is a vast country and soil conditions vary from place to place. Somewhere we have black cotton soil, somewhere we have rocky terrain, alluvial soil. So depending upon water table and soil characteristics, you have a foundation reach up to the plinth level, and from plinth level above you start using these new technologies. I think I have a slide that also I'll show you. Okay, so once you come at the conventional print level, till that print level, the time taken by the project is similar to your conventional and project conventional foundation. Over and above that, the time is greatly reduced. Okay, so this is again a view. Then you can see here. So what you see in this topmost left corner. So this is how. So up to plinth level, this is conventional construction, and then you leave these dowel bars, and then you erect the reinforcement, erect this aluminum formwork, okay, and then do the casting, then take to the next floor. Okay, so this is that formwork, and again, as I've been telling you repeatedly, day after tomorrow there will be specific 3-hour lecture on this technology, one by CPWD engineer, and then by industry expert from L&T. Okay, so these are the stages. You come to the plinth level and then do like this. You can see this is the again a finished mass house project under PMAY using this. And as I told you, several lakhs, several thousands of houses are being constructed across the country using these technologies, and there are many advantages with this technology. There is another variant. There are a number of variants of this technology. This is called tunnel form, and again this will be explained tomorrow. So here what we are doing is we are making the formwork for the entire the dwelling unit, so all the 4 walls and all. Here only 2 longer walls are being cast, so it creates a tunnel kind of thing. And this technology we have used in one of our lighthouse projects in Rajkot, which I will be showing you, and that project was completed in a record time. And here this in Rajkot we used tunnel form, and the building is S plus 13, 14-story building, and the entire 14-story building, each floor had, 8 dwelling units. The entire thing was cast in 45 days, the entire skeleton. So this tunnel form, along with slab, it was cast in 45 days, the 14-story building. Okay, and that we have done in Pradhan Mantri Awas Yojana under Lighthouse project. We have achieved that, and the project has already been handed over to the beneficiaries. So you can see tunnel form is a mechanized system for cellular structure. It is based on 2, inverted L form of this. So it creates a tunnel kind of thing with slab, and then outer the remaining walls you can have infill walls, or you can have a sandwich panel kind of system. Okay, again, so here wall and slabs are cast in a form of a tunnel, leaving 2 sides open, whereas in monolithic concrete construction, the entire room is cast in a single pour. I hope you understood this. So here you are casting slab and 2 longer walls, whereas in monolithic concrete construction or the other formwork, aluminum formwork, you are casting the entire room in a single. Okay, so this is faster, and again, a lot of people have used it, this technology. Another important thing I wanted to tell you is that, one of the major impediment when we introduce this technology in the construction sector, especially in government sector, is absence of schedule of rate and specifications and absence of certification. So already CPWD has included this in their schedule of rate. Also, there have been office circular by CPWD and even Ministry of Housing and Urban to use this technology in future projects. Also, National Building Code 2016 give reference to this formwork systems. Okay, and as I told you that we are operating a scheme called Performance Appraisal Certification Scheme, which is through Gazette notification of Government of India. We are authorized to certify, evaluate, and certify new technologies. So we have also certified these technologies. Okay, so this is the first formwork system. So here, what you see, this is a typical formwork system which is customized, made in the factory. And once the casting is done, you remove this formwork and give it back. There is another kind of formwork which is not removed, but which stays with the structure. Okay, and because it stays with the structure, that is why it is called stay in place formwork system or lost formwork. Some of you might be knowing lost formwork system, so this is called stay in place. I have given it name stay in place. It is also known as lost formwork or sacrificial formwork system. And this formwork system again is of two type. One is insulated concrete formwork. If the formwork acts as an insulation, then it is called insulated formwork system. If it acts as a part of structure, as a part of reinforcement, then it is called a structural stay in place formwork system. Okay, and I will show you through pictures. I'll try to explain you through pictures. Also, as I told you earlier, that for most of these categories we have created audio visual capsules as well. Okay, so those films on your dashboard, there is a link of our YouTube channel. So through that YouTube channel you can play those films and know more about these formwork systems. Okay, so let me just explain you. So this is that. So there are two types. First was formwork system was in engineered formwork system, aluminum formwork. This is stay in place or lost formwork system. So if it acts as an insulation, then it is called ICF, insulated concrete form. So this is like this. So here what we are doing, all of you know, this is a typical framed and infill wall construction. How about replacing these walls by this kind of formwork? So this whiter element which you see is expanded polystyrene. Expanded polystyrene, if you don't able to understand, this is nothing but a treated thermocol of higher density. The density of thermocol is 1 kg per meter cube, 1 to 5 kg per meter cube, but this has density more than 15 kg per meter cube. Okay, and its name is industry name is expanded polystyrene. Okay, so this is this formwork. So you get these kind of blocks made in the factory, and then you just keep on in a single two-man can insert this and create an entire wall, and then you, depending upon your project size, depending upon the design, you can insert the reinforcement and then do the shotcreting. You can fill the cavity with concrete or with lightweight concrete, or you can, depending upon your structural requirement, keep it without any concrete, and then do the shotcreting from both the sides. Okay, so this acts first as a formwork system, and then it stays with the structure, and later, because it is a expanded polystyrene, so it acts as an insulation, and that is why it is called insulated concrete formwork system. Okay, so we are replacing cast in situ formwork by factory made this expanded polystyrene formwork system, and this is called sacrificial formwork or lost formwork. Means formwork is left in the structural system to later act as a insulation layer. So there are several companies in our country who are into this kind of formwork system. You can see. So any joint. So again, remember another thing I have been telling you, that all these technologies are customized or tailor-made. Tailor-made means you go to a tailor and as per your size, as per your requirement, he or she stitches a jacket or a shirt for you. Similarly here, as per your project requirement, as per your plan layout, the agency will make these building blocks or these formwork systems for you in the factory, customized and then being given to you. So L, T joints and everything, those depending upon the size, depending upon the height. Okay, these formworks are manufactured and then brought to the site, and then on the already laid plinth. Again, foundation is conventional, so you have to reach up to the plinth level, reach the double bar, and then over and above that you will put this. Again, for this technology also, we have an industry expert from Mahindra Lifescape. He will be giving a lecture on this along with a scientist from CBRI. They will be discussing this technology in detail with you. Okay, so I think the basic premise or the basic background you understood, that this formwork is left in the structure. That is why it is called stay in place formwork. And then these are two, and depending upon this, the thickness can be 150 as per your fire requirement, as per your structural requirement. You can have more width or thickness, more thickness. Okay, and you can put reinforcement and other things also. You can see this, and you can see this is a closure look again from India. So this is how it is being put, and once this is being put, then you do the concreting. You can fill the cavities or you can leave the cavities as it is, and then both the sides you can do shortcutting. One of another initiative taken by our ministry is demonstration housing projects. So BMTPC, my organization, only in order to popularize these technologies, in order to learn more about these technologies, and in order to train artisans as well as our professionals on these technologies, what we are doing across the country in different states with these different technologies, we are constructing demonstration housing projects. We are around 40 houses we construct using these technologies. So we have used these technologies in Bhopal, where we have constructed a sports hostel uh, using this technology. Okay, so I think you understood this. So as I told you, because these technologies are branded, so there are a number of companies who are making it. So each one of them call them by their own name. Okay, but the basic name is insulated concrete form. So there is a company called Reliable Insupac, so they call it ICF. Then there is a company, another company, MyWear from Hyderabad, Ecotech Private Limited, they call it monolithic insulated concrete system. And as you can see, all as per your project requirement, all these elements, corner element, so anything, you can have curvilinear, you can have column, you can have T, you can have C, you can have corner joints. So all these are being made manufactured in the factory, and they are separated through that black thing. What you see is a plastic tie. Okay, and then they are assembled at a site and they have tongue and groove, slip and lock arrangement. So through tongue and groove you create entire thing, and then do the concreting from both the sides. Okay, so you can see here that this system consists of two layers of modules, that is expanded polystyrene, this white thing, separated by hard ties. These modules are interlocking, as I told you, tongue and groove kind of system. They are interlocking modular units, and then they are dry stacked over the already laid plinth, and then filled with cast in situ concrete. The units lock together and create a form of structural walls. They can be used as a slab for even for a staircase slab, even for sunshade. They can be used for any application. And then you do the shotcreting. When cured, the wall supports the structural loads from floors and roofs, and shuttering provides this shuttering, because it stays in the structure, it provides thermal insulation. And as I told you, that you can put the reinforcement in between the cavities as per your requirement. Okay, then so this was about ICF. Then there is another category, which is when the formwork acts as a part of structure. So again, it is a sacrificial formwork or lost formwork left in the structure, but here it acts as a reinforcement. So I will show you next slide. Again, the basic premise you understood. So instead of brick by brick wall, you have this kind of formwork, do the concreting. So, and it stays in the structure. So later it acts as a flexure and axial reinforcement, flexure and shear reinforcement. Okay. Again, I have used this technology in several demonstration projects. One project we have done in Bihar Sharif, where we have created 40 odd units using this, and then again another project project we have been in Hyderabad, where we have used a training hostel in one of the building centers where we have used this technology. So you can see here, it is like this. Again, this is Coffer is the name of the company, which is who is manufacturing this formwork. Again, it is customized as per your requirement. These panels, these Coffer panels are made in the factory and then brought to your side. And this formwork system can be used as a load bearing system. So there is no need to have beam columns. You can just erect these panels, which are galvanized. I will show you. So these are galvanized plain steel sheets with a mesh with a rib lath reinforced by C profile GP sheets as vertical stiffener. I'll show you another slide. Then these grids are further connected by MS rebars. Okay, I think, yeah, you can see here. So this is how. So these are this is a panel which is made in the factory, and then over a plinth you put this and then do the concreting. So here you require a sticky concrete, less flowable concrete, and then you do the concreting and then you do the plaster. So this first acts as a formwork, and then later it acts as a structural steel. Okay, so after the erection of formwork panels in alignments, corners, edges for doors and windows with rebar positioning is placed, then you put the concrete of required size is poured, and then once the concreting is done, then walls can be finished with plaster. Okay, so this is simple, and again this walls can be thinner because you are using this formwork, and this is a galvanized sheets. Okay, so it's nothing but a galvanized plain sheets. This panel is made. Okay, again this technology again has been included. The technology which I showed before, ICF, is also included by CPWD in their schedule of rates, and again this technology very recently this has been included in CPWD specifications. So I think it is clear to you. So again, as per your requirement, you can have as many stories as you want. If you want to have more number of stories, so you can put the reinforcement, you can increase the thickness of these panels, and these panels are galvanized panels, as you can see, erected like this. Panels are brought from the factory, and then you do the concreting. And there are other agencies, as I told you, that for lost formwork system, there are other formwork systems which are available. Lost formwork, you can see here, if you are able to see here, what we have fiber cement boards. Okay, so again there will be a lecture on the sandwich panel system, detailed lecture, but just I wanted to show you, introduce you this technology. So fiber cement board, both the sides, and they are connected together by this you can see these stiffeners, or this is called high impact molded inserts, so spacers. So through these spacers they are connected together, and you can have this fiber cement board 6 mm or 8 mm or 10 mm thickness, and then they are just dry stacked at the side, so they come of suitable width and height, and then through a tongue and groove connections they are erected at the side. So these panels are erected in situ to produce straight to finish panels, and thus you can create a monolithic and this thing, and this the cavity inside can be filled with suitable grade of concrete depending upon the application. If you are using it for non-structural application, then you can fill it with the lightweight concrete, or you can leave it as it is. Otherwise, if you want to use it as a load bearing panel, then you can use it with you can fill it with concrete. So the basic premise here is that you are having these skins or sheathing. Outer skins are fiber cement board, or it can be calcium silicate board, or anything, and then they are separated by plastic inserts in between. Okay, so there is a company, as I told you, they are branded. So there is a company which is manufacturing it with the name Plaswall. So there are other companies. Everest is also making with like Aerocon panels. I'll show you that as well. There are a number of companies who are making. Everest is also making these kind of panels. So this company, they make it in for non-structural application. If you want to use it as non-load bearing applications, then you can just leave it as it is. Otherwise, you can fill it with concrete. Okay, so this is called this kind of. So again, same thing as you can see here. These are the what black thing you see is the spacers, and you have a fiber cement board. And as I told you that for the entire room height, they are manufactured in the factory, and then they are put side by side. Normally, the width is around 1 meter or 600 mm, 2 feet or 1 meter. Again, it will depend on the size of your room and project size, and then they have tongue and groove arrangement. You have to put a channel. Again, there will be a detailed lecture, so I'm not going into detail. I just wanted to explain you that this is a drywall panel. Okay, and it can be used both for non-load bearing applications as a filler wall, okay, or as a structural wall. Okay, so if you want to use it for structural application, then fill it with the pour the concrete. If you want to use it as a infill wall, then you can, or as a partition wall, then you can fill these cavity with a lightweight foam concrete. Okay, so again, the same thing. Here it is, this already explained you. This is again EPS, expanded polystyrene. So again, this is the entire panel which is made in the factory. We have used this technology in one of our demonstration housing project in Lucknow. So expanded polystyrene panel with welded wire mesh. I think another slide I'll show you. There is another very interesting technology which is called a stain place PVC wall forms. Again, there will be a detailed lecture on this. So you see this. This is a wall form which is pre-finished wall. Okay, pre-finished wall means you can just buy this wall from the factory and just erect it, and it is pre-finished. Means what happens here is, here the outer whites you call, or sheathing you call, or these outer layers are of PVC. Okay, and this PVC can be, you can have different color options. So it can be white, it can be gray. So you can give the order, so they will make it in that color, and there is a cavity in between. Okay, so again, if you want to use it for load bearing application, fill it with concrete and reinforcement. Otherwise, for partition walls or for infill walls, you can use it as it is. So this is pre-finished wall, and this is brand new technology which we are using in one of the lighthouse projects in Lucknow. Okay, and you can see this. So that is why it is called PVC wall form. And as I told you that again, these are the names given by these are branded. So there are two companies in India who are making this PVC wall forms. Okay, so PVC, all of us know, polyvinyl chloride. So PVC, so the finish is PVC, and in between there is a cavity, as you can see in this. So these are extruded components, and as you can see, this is 600 mm wide, and it comes up to a floor height. So if your floor height is 3 meter or 2.6 meter, they will manufacture or customize it in that form only, and then you, through a slide and lock arrangement, you can create the entire wall, and then later you can insert the reinforcement through this cavity, and then pour the concrete in between the component. Okay, so the hollow, there is a company called Novel Assembler, they call it Novel Wall. There is another company called Kaljan, they make it with their other names. So these wall components are erected, and in abroad they have a kit. So they call it DIY, do it yourself kit. So these PVC wall components are, they have a usual manual, and on a plinth you just keep on erecting these walls through slide and lock arrangements, and to create the entire house. Okay, and they can be used for slab operations as well. All services you can put by cutting the groove, or window door frames and all those things. So those details will be shared with you in the specific lecture of this technology. So I think you got the idea, and this falls in this stay in place formwork system. So there is another company who have given it this name, permanent wall forms. There is a Hyderabad based company, Kaljan, and they have made it like this. So you can see, so straight to finish with the door and window finishes. You can insert door finishes, all finishes you can put, and then pour the concrete. Okay, so the extruded components slide and interlock together to create a continuous formwork with two faces of wall connected together by continuous web members, forming hollow rectangular components, and these you can have these T joint, corner joints. Okay, so you have these components, then a specific component for corner is manufactured in the factory. So as per your requirement, these corner elements, T elements are made, and then they are erected on the already laid plinth, and then in between you can insert the reinforcement, because it has cavities from both the sides, vertical cavities as well as horizontal cavities. So you can put horizontal as well as vertical reinforcement, and then once the walls are erected, they are filled with concrete in situ to provide a monolithic concrete wall. Okay, there is another technology. Again, there will be a lecture, so I'm skipping this GFRG, glass fiber reinforced gypsum wall technology. Again, this is one of the indigenous technologies. This technology came from Australia earlier, but then IIT Madras along with BMTPC did a lot of research on this, and this is based on a waste material which is phosphogypsum. So phosphogypsum is a byproduct of a fertilizer plant, and from that these panels are being made, and these are called GFRG, or glass fiber reinforced gypsum walls. So tomorrow the first lecture will be on this technology by Professor Meher Prasad. So I'm not going into details of this. Again, this is a wall panel made from a waste material which is phosphogypsum, and it can be used as a slab, as a load bearing wall panel. Okay, you can see this is again he will show you. So you can see, so this panel comes like this with the cavities. You can fill these cavities, alternate cavities as per your design with the reinforcement and concrete. You can use it for laying the slab as well. So every every third cavity is cut, and you can put a reinforcement and cast a beam there. Okay, this I'm not explaining. So this is the panel you can see. So for this panel comes of this form. So for the entire room, okay, this comes, and this is a 3 meter wide. It's a lightweight because it's a hollow, and then it is inserted on a already laid plate. These are the pictures from a guest house which was constructed in IIT Chennai. Okay, so I'm not going into detail of this GFRG because this will be explained to you tomorrow. Then let's move to next category. So far I have explained you two categories. One was form engineered formwork or shear wall construction on aluminum formwork. Then another category I explained you, which was stay in place formwork, where formwork is not removed, but it is left in the structure to be part of structure. So if it is part of structure, either it acts as a insulation, or it acts as a part of structure. If it acts as a part of structure, then it is structural stay in place formwork system. If it acts as a insulation, then it's called insulated concrete formwork system. Now let's move to another very exciting category, which is dry wall construction, and it is known as prefabricated sandwich panel system. Okay, so again, sandwich panel system. Why it is called sandwich panel system? Because there is a softer core which is sandwiched between two outer layers. Those two outer layers can be fiber cement board, calcium silicate boards, MgO board. It can be AAC panel. Okay, so Aerocon panel you might be knowing. So you can have that kind of panel. So there is a softer inner core, and then you have whites or sheathing, or you can call it skin. So outer skin 6 mm, 9 mm fiber cement board. That is why it is called sandwich panel system. So a core, softer core is sandwiched between two skins or two sheathings. That is why it is called sandwich panel. So through this slide, I'm trying to explain you what we have conventional. We have this kind of system. Okay, what you see on the left hand side. So this is a typical wall in English of Flemish bond. Then you have bricks or blocks or concrete hollow blocks, and then you put the plaster, or there are variety of there is another alternate system, rector bond. You can have this. So what about replacing this entire thing by these kind of panels which are made in the factory, and there is nothing else is required, no formwork, no scaffolding, nothing is required. And most of us know about this kind of system which you see on a bottommost left hand side. This is PPGL. Okay, this is a puff panel. Okay, so it is galvanized, pre-painted galvanized puff panel. So you have core is of puff, and then both here you have galvanized profile sheets. Okay, most of the, and this is used for industrial structure. So instead of profile puff, you have a expanded polystyrene, or and then instead of this profile sheets, you can have fiber cement board, calcium silicate board, AAC panel, or anything else. Or otherwise, you can have a EPS panel, and both the sides you can do the short plating. So in general, it is called sandwich panel system. Okay, and I will just show you through pictures. You can see here. So replacing replacing brick and mortar walls with these dry customized walls made in the factory. So this entire wall with cuttings, you can create these openings at the site, or they can be customized and cut at the site. So instead of brick, you can have this kind of panel. And as I told you, these panels come in variety of ways: EPS panels or other kind of sandwich panel system. And there are a number of companies. Everest is making it. Then Hyderabad Industry. There are a number of companies who are making these panels, and they all these panels come in their variety of ways, and they can be single layered or double layered. I will show you pictures. Okay, so first is EPS core panel, which is also very popular. As I told you, EPS is nothing but treated thermocol of higher density, and this is the panel. I think I have yeah, you can see this. So this is called EPS core panel system. Again, detailed SOR of this has already been issued by CPWD. So what you see here, this is the core. So this is a softer core which is of EPS. Then you have welded wire mesh on both sides, and these two welded wire mesh are connected together through stiffeners. Okay, through a stiffener, these are connected. So these two welded wire mesh create a space struct, space truss like thing. So which helps in which helps in load transfer, or which helps in bearing the load of the structure. So this can be used as a load bearing wall panel, and it is called, since it is of EPS, it is called EPS core panel system. So core is of EPS, both sides it is welded wire mesh, galvanized welded wire mesh, which is interconnected through stiffeners, and then you can do the short plating from both the sides. Then you can see, as per your requirement, as per the money available, finances available, you can put a board, you can do a plaster, you can do a short plating, and this panel can be a single panel, or it can be a double wall panel of this kind. Then it can be used for as a wall panel, it can be used as a slab panel. If you want to use it as a slab panel, you have to create a cavity and put a reinforcement and do the concreting. It can be used as a staircase panel as well. Okay, and there are more than dozen companies in our country who are making this EPS core panel system, and it is being widely used. One of the interesting application of these panels is, if you nowadays, because of urbanization, because of rise in population, because of requirements, you have to add another story in already existing buildings. Suppose you have to enhance the capacity of a hospital, or if you want to enhance the capacity of a school or any other institutional buildings. And so you can quickly erect another story by using these things. In Calcutta, Kolkata, the older Kolkata, there are a whole lot of old structures, old monumental structures, and they have very thick walls of British era, and all those structures are in dilapidated conditions. So they wanted to refurbish it. So what they did, they have just removed these walls and replaced these walls by these EPS core panel walls. Okay, so that is one application. We have used this in several demonstration housing projects. Right now, we are doing a project in Jammu where we are making 40 dwelling units using this EPS core panel system. So I think again there will be a detailed lecture on this technology as well for all of you. So I think you understood this EPS core panel system, and I've been telling you these are customized technologies, branded technologies. So there are a number of companies, and they give them their own names. So there is a company M2 MUD which calls it Advanced Building System Panel System. So you can see again on an already laid panel, already laid plinth, you have double bars, and then you erect this, and then you cut the opening, you can put the services and all those things here. You can see this is that galvanized welded wire mesh I was talking about, and here you can see this is the plinth. Then you leave these double walls, and then you put a channel, C channel, and over that you erect this core panel systems. Okay, and then you do this kind of so you can have this kind of short plating, and then you can do the plaster. Okay. You can see this is being used here as a floor element. Okay, for a slab. So it is being used. This is the finished house again under Pradhan Mantri Awas Yojana. So once you finish the house or finish your building, you just can't make out whether it is concrete wall or it is a brick wall or it is a EPS wall. Okay. And as I've been telling you, there are a number of companies. There is another company called Birdhouse, which is making these panels with a name called Rapid Panels. Okay, so again you can see this is welded wire mesh, two welded wire mesh interconnected through stiffeners, and in between you have a core that is expanded polystyrene core. Okay, and as per the project size, these panels are customized and made. Then there is another Jindal Steel is also making these panels, and they call it reinforced EPS core panel system. So that is the name given by them. You can see here in this. So this is a slab. These are the walls, and wherever you have corners or openings, you can put additional reinforcement. Okay, so it can be designed, and they have ready-made softwares available for these technologies. So through that software, the reinforcement requirement and other requirements can be found out, and then it can be incorporated in your design and at the construction site. Again, this technology has already been certified by us. It has already been included by CPWD to be used as wall panel, load-bearing wall panel, or non-load-bearing wall panel, and as a slab. So as you can see, panels are finished on site by spraying concrete to realize the different structural elements, vertical structural walls, horizontal structural elements, slab floors, or cladding elements. Even sunshades and all can be made with this. And if you're really interested to see or visit, you can visit our Jammu project. We are doing a demonstration housing project there. Then there is a well-known company, Bird Shell. In fact, we are using this Bird Shell panels in that Jammu project. So again, it comes with the name Quick Build 3D panels. Okay, then there is a Schnell. You might heard of the Schnell India. Schnell is a German company which has a patent on this technology, and they normally supply equipments for this for setting up a manufacturing plant of this EPS panel system. So they also have a panel with name concrete wall. So idea here is just to give you that there are umpteen number of companies in India who are manufacturing these EPS core panel systems. Okay, Bow Panel, again another company from Switzerland which is making, and they all have a setup here in our country, and most of these technologies which I'm talking to you, they have already been certified, whether it is this M2 or this rapid panel, Jindal, Bird Shell, or concrete wall of Schnell India, Bow Panel, all of these have been certified by BMTPC under performance appraisal service. Then that was EPS core panel system. Then another kind of panel, sandwich panel system is this, and all of us know about Hyderabad industry, so they produce this kind of sandwich panel. So this is a lightweight. This is a aerated concrete or lightweight concrete, which is sandwiched between two fiber cement board. Okay, you can see here, and this you can see this joint. So this is a tongue and groove joint. So this is around 2 feet, and it comes of a full room height. So these are customized, made in the factory, and then you over already laid plinth, you just erect these panels, and through slide and lock arrangement, the entire wall can be made. Okay, so this is for non-load bearing application for partition walls. So if you want to use it for load bearing application, then you have to have columns and beams, otherwise okay. And why it is sandwich? Because this aerated concrete or lightweight concrete core is sandwiched between two sheathing or two skin or two facing sheets, and these facing sheets can be fiber cement board, or it can be calcium silicate board, or it can be aerated. Some people are using precast concrete panel as well. Okay, so there is a company which uses precast. So Vishaka Industries, there is a company which are using precast concrete panel or their own panel. Okay, so you can see here two fiber reinforced cement facing sheets on either sides of a lightweight concrete. And as I told you, they have a tongue and groove jointing system that facilitates rapid construction, and they are fully cured in the factory itself. Okay. Uh, Then there is another technology in this, which is Rising Japan. There is another company, and this technology we are using in one of the lighthouse projects in Indore. We are doing a project in Indore where we are using this sandwich panel. Again, similar panel, but here we are they are using the elevated concrete. I'll tell you what is elevated concrete, and facing sheets are calcium silicate board. So again, as I told you, the names are given by the company. So this is their branded name. So they are calling it EPS cement panels. And the company name is Rising Japan Infra Private Limited. These are lightweight composite walls, floor and roof sandwich panels. So these panels can, again, this is again included by CPWD. These panels can be used for wall applications for as well as for roof panels. So we have a calcium silicate board on both the sides, and the core is in this was a lightweight concrete or aerated concrete. Here they are using a special concrete which is made of EPS granule wall. Remember I told you expanded polystyrene, so it comes in a granule form also. So instead of aggregate you have those granule walls, then you have cement, sand and fly ash, and with that you make a concrete which is known as elevated concrete. So this entire panel is made in the factory. Again, it comes of a full room height or a specific height and tongue and groove system. So the entire panel can be erected at a site. And this panel we have used in one of our lighthouse projects in Indore, where I think G plus 8 or it is G plus 13. I will show you in a slide. The structure is being made. And since this is, we have recommended this technology only for non-load bearing applications. So we have used a steel structure with this panel as an infill wall panel. Okay. So then again, there is another panel. There are two companies who are making this kind of panel. One is Rising Japan. There is another company from Gujarat, Bharga Infrastructure, which is making this EPS cement sandwich panel system. So EPS cement sandwich panel system means fiber cement board or calcium silicate board on both the sides, and in between you have a EPS, that elevated concrete, which is made of expanded polystyrene beads, cement, sand, and fly ash. Okay, so there are a number of another company, Covestro. They are making a panel where they are using fiber cement board of 10 mm thickness, and these panels are filled with another material called PIR, which is polyisocerate. Okay, so with this, and this is again used for non-load bearing application, and they call it PIR drywall. So it is a completely drywall system. So you have a steel structural system, steel columns and beams, and then in between you can have this kind of panel. Okay, so fiber cement board, and in between you have this insulation material. Then there is another famous company called Vishaka. They are making it with a name called V infill wall. So they call it Vishaka infill wall panel. Again, same thing. You have a fiber cement board on both sides, and in between you have a elevated concrete. Okay, then this is very interesting technology. Here they call it nano living system. I remember I told you about health of the occupant, the persons residing in the house. What about the inside air quality? So there is a company from UK. They are making this MGO. So MGO panels, and MGO is magnesium oxide. So what they are replacing fiber cement board by magnesium oxide board. Okay, so you have magnesium oxide board as facing sheets. Okay, and in between you put a lightweight concrete, and it is claimed that this MGO reacts with the reacts with the carbon dioxide of the atmosphere or inside air, and thereby creating a healthy environment. Okay, so MGO panel, and that is why they call it nano living system. So MGO reacts with carbon dioxide of the atmosphere, and thereby creating healthy environment inside. So just think the kind of innovation, the kind of things have gone into the construction sector. So a wall is being made which can help create a healthier environment inside. Again, so this is again a sandwich panel system. Now by this time you know what what do I mean by sandwich panel system? Again, the spacing, the thickness of this wall can be 150 mm. Then you can have this spacing sheet of 10 mm or 8 mm, depending upon the requirement. Again, the technology is recommended only for 4-story, G plus 3-story. If you want to use it as a load bearing panel, then you can use it up to only, we have recommended this only up to 4-story structure. So this was this precast sandwich panel system, and as I told you, there will be a specific lecture from a scientist from CBRI who will be discussing in detail about this sandwich panel systems. Now let's move to fourth category, which is steel structural system. Dear friends, all of you know that steel is a versatile material and better material than concrete when it comes to earthquake resistance and making high-rise structure. And there will be we are dedicating 2 sessions. One entire session on light gauge steel structural system will be taken by a very renowned professor from IIT Hyderabad, who will be talking about light gauge steel structural system, their equipment, how to design this, how to construct the buildings using this, what kind of infill materials you can use. And there will be 2 lectures again by IIT Kharagpur professors who will they are basically architects who will be talking on hot rolled steel structural system. Nowadays, again, steel structural system have become very popular because the technology has changed. Nowadays we have TMT bars, and steel technology has changed, and now we can make built up sections. Okay, remember earlier we used to have hot rolled steel sections, eye girders, channel sections, angle sections. Nowadays we can have hollow built up rectangular sections. So those hollow built up rectangular sections have opened up have opened up a lot of flexibility into the structures, and you can use them for making a whole lot of different kinds of structure, and replace RCC beams and columns by these built up sections. Okay, and in all of our lighthouse projects, wherever we are using sandwich panels, we are using these built up sections. There are 3 projects we are doing. One in Agartala, one in Indore, one in Lucknow, where we are using these built up sections for beam and columns. Okay, so built up sections, you all understood that instead of hot rolled I sections or a channel section, you can have a built hollow rectangular built up sections. Okay, so let me just show you this again. You can see here. So replacing cast in situ RCC structural, RCC beam and column structural frame by this kind of system. Okay. So these again, as I told you, nowadays instead of rolled sections, you can have built up I section or built up hollow section. If you are having low rise structure, then you can have built up hollow section. If you have a high rise structure, then you can have I section or have any kind of cross section as per design. Okay, so of course there is a whole lot of saving and speed. You can fast track the construction, because instead of making beam column curing, you can just get them manufactured in the factory, and then just put this, and then you can have whatever drywall systems I told you. You can just insert those walls as infill walls here. I think I will show you that as well. Okay, so I think the basic understanding you must have got now. There will be few lectures on this technology as well. And let me also tell you that whenever we talk about these new technologies, the entire concept, it is done in a very professional manner through, you remember we used to talk about CAD, computer aided design, design and manufacturing and construction. So entire thing, the entire thing is fed into the computer. The entire your plan, layouts, elevation, the entire design process, and then through your software you get how many components are required, what kind of components are to be fabricated. So entire thing is mechanized, automated, and then you fabricate those components in the factory. Then in the factory itself, you can give the provisions for services and other things, then transport it to the site, and then just erect them at the site. Okay, so entire thing is automated process, right from the concept stage to the construction stage or handing over stage. You can see this. There is a company called InstaHome. InstaHome means instant homes. So they just make the entire thing for you, including finishes and this kind of thing they can make. Okay, I'll show you. You can see this. Okay. I just wanted to show you this. So, this what you see. This is a very interesting 10-story mall, which was, constructed in the outskirts of Chandigarh. You all know about Mohali. Now, Mohali is quite famous for a cricket stadium. So, it's an industrial town in the outskirts of Chandigarh, where this mall was constructed in 48 hours. Okay, this mall was constructed, and it was constructed, I think, in 2014. This mall was constructed, and the entire operation was seen by then Home Minister. And the technology was not new. You just can't make out, but the technology is this. They have used steel beam and columns, and the walls are that EPS. You remember I told you EPS wall panels. So they have used EPS wall panels here, and they have used steel. So by the time you do the foundations, you give the order for beam and column to the factory, steel factory. They will manufacture or manufacture those beams and columns for you, and then you just bring them to the site with all services, everything, and then just erect them, assemble them, and start using them at the site. Okay, so since then this technology has been being used, and nowadays, another interesting thing which will be explained to you in one of the lecture of steel. See, even Ministry of Steel is asking all the line ministries to enhance use of steel in all their activities. So construction sector, we are also promoting use of steel. We use steel as reinforcement, but use of steel as a structural system for beam, columns, trusses, and other things. Use of steel is being promoted because the technology has changed. Now we have built up sections and all, which has opened up new areas and given a lot of flexibility. There is economy also when you use these built up sections. Okay, steel, and because steel behaves quite good in tension as well as compression, so it is quite good for earthquake resistance as well. So you can see this for quickly rehabilitating, in case of disaster and all, it can be used. It can be used for quickly erecting or quickly rehabilitating people. This is a slide. This is near Dehradun. Some officers' mess and other structures for Ministry of Defense are being made by the same company. So these columns and beams and were made, manufactured in the factory, and then they are putting the EPS. And here the slab is deck slab. So deck slab, all of you know. So you put a profile sheet, and over this you put a nominal reinforcement, and then you do a screed concrete to create a slab. In fact, I have used this technology after Hudud cyclone. We were asked to give a technology which can quickly rehabilitate the displaced people during Hudud cyclone. So this was a technology we gave. So these are these. Again, you can see these. This is near Vishakhapatnam, and Vishakhapatnam is a coastal area. So we have given them coating and all. So steel structure with deck sheet, and these are aerocon panels. So this for infill you can use anything. So basic thing is structural system. Structural system is of steel. Slab is deck slab, and then these walls can be EPS panel, sandwich panel, puff panel, as per your requirement, as per the utility of your building, as per the cost available. You can have these infill walls, and this comes out very cheap. Okay, this is for industrial structure. All puff panel with the. So this is a puff panel where you have a this puff. Puff is a core. All of polyurethane foam, which is bonded between two PPGI sheets. PPGI sheets are pre-coated GI sheets. So PPGI sheets are profile sheets, and in between you have puff. So mainly for industrial structure, this puff panel with the steel structural system is being used. Okay, then there is another again sandwich panel with puff panel. It can be used. another. There are a number of companies who are making it. Hyderabad Industry is one. And let me tell you that these, during COVID time, most of these panels were used for quickly erecting the hospitals and other things, quickly erecting the infrastructure for COVID patients. Okay. Then there is another uh, technology which is light gauge. All of you know about cold form steel can be manufactured in two ways. One is hot rolled steel and one is cold form steel. So cold form steel is nothing but made from galvanized sheets, galvanized thin steel sheets. They are put in a press to form different jet sections and other sections to create light gauge steel sections, and these light gauge steel sections can be converted into wall panels and then can be used to make low rise structures up to G+3. And as I told you, there will be a lecture of 3 hours by a professor from IIT Hyderabad. So I'm not going into detail, I'll just show you a few slides. So this is how it is being done. So you're replacing, and this is a very popular technology. I will give you an anecdote also on this technology. First, let me explain. So this RCC frame construction is being replaced by this kind of light gauge structural system. On the slide, I'll show you. So these light gauge panels are made in the factory. And this is again, Jindal Steel, they have a plant near Raipur. So they have created an entire township using this light gauge panel. And we have recommended this technology only up to 4 story. Abroad, Hong Kong and other places, they are using it for high rise. But looking at our geo hazard profile, we have recommended or certified this technology only for 4 stories. So the frame is made of cold rolled high strength steel section, and then this in between space you can put a fiber cement board or EPS panel, and in between you can put you can infill it with mineral wool, okay, or rock wool. Okay, so rock wool and infill wool. And again, light gauge steel, this has already been included by CPWD. Detailed schedule of rate has also been created for this. Also for cold form steel, we have a code, long back, IS 800, all of us know IS 800 is for steel structures. Similarly, IS 801 is the code for cold form steel. It was made long back, and now they are revising it. But cold form steel we didn't use because it was replaced by concrete. Now again, it has become very popular, and it is being used for adding another story for quickly erecting the structure. And as I was telling you, during COVID time, Hyderabad Industry and other people, they made a lot of hospitals, COVID isolation centers and other facilities were created using this technology. So it can be done very easily in a factory. You make these light gauge panels, and then over already, if you're making a single story house, then you don't require a foundation that deep. So quickly you can just make these panels, put the fiber cement board on both the sides, and then just start using them, putting the services. Okay, so during COVID time, you remember, I always tell my students that during COVID time there were two WhatsApp messages which were, which were circulated very aggressively as regards civil engineering. That there was a hospital made in Russia and there was one hospital made in China. They said that immediately they made the hospitals. So we were asked, then how can they do it? So what was the technology? Now I think this the technology. The technology was nothing but this light gauge and steel structure. So what they did, they just put the steel structure and then covered it with this wall sandwich panel system which I showed you. So that was the technology, and we were also given a task that can we do it. Then we suggested our ministry that yes, it can be done easily, and in fact MVCC engineers are there. So that time the CMD and I, we both sat together and we gave the entire scheme of plans, but somehow that project didn't realize. So all I wanted to say is that this technology can be used for variety of applications, and very quickly you can erect this structure without compromising structure and functional performance. And as I have been telling you, all these technologies are ably supported by computer-aided design software. All sophisticated tools complying to our standards are available. So you can create the entire model, virtual model, 3D model, go-through model, walk-through model. Everything can be done and suitably designed. And then later it can be given to fabrication team for fabrication and then brought to the site for assembly and other things. Okay, so you can see here, so this is that light gauge panel I was talking about. They are made in the factory, and then both sides you can see this. These are the fiber cement boards from both the sides you can put, and in between you can put the rock wool, mineral wool with vapor barrier, or the other instead of fiber cement board you can put any other board, EPS panel like I calcium silicate board you can put, or some of the agency they are making a precast concrete, thin precast concrete panels they are putting instead of fiber cement board. So as the company, they can put any kind of sheeting elements. Okay, you can see this. Here they are using precast concrete panel. Okay, so there are a number of companies, as I was telling you, this is that precast concrete panel. Okay, so there is a company from Bangalore. They are using light gauge steel frame structure with precast panels. Okay, and these precast panels are filled with lightweight concrete. So in between, you can put a rock wool or mineral wool, and if you are not happy with mineral wool rock wool, you can fill it with the lightweight concrete. Okay, and lightweight concrete you all know. So this was about steel structural system, and now let's move to the next category, which is the most promising one, precast concrete construction. So precast concrete construction, again 2 days we will be devoting for this precast concrete construction. One day will be on 2D precast. So entire its manufacturing, its transportation, its design, its joints will be discussed with you in detail. And next one day will devote on 3D volumetric construction, where the entire module is being made and one over the other. And we have two very prominent industry experts who are actually doing. One has already done up Goa International Project, Goa International Airport, which was recently inaugurated by Honorable Prime Minister, was made with 3D volumetric construction. So we have the CEO of that company who will be delivering a lecture on that. And another project which we are doing in Ranchi with 3D volumetric construction using a with a company Magicrete of Gujarat. So their CEO will also present the 3D volumetric construction. Those two lectures are going to be very interesting. So they will explain you in detail. Then we have a scientist from CBRI who will be explaining you the different aspects of 3D volumetric and precast concrete construction. Then we have a professor from IIT Madras who will be delivering a lecture on precast concrete construction, its design aspects and other things. So the basic premise, as you know, for 2D precast concrete construction is simple, as I explained you earlier as well, that you are replacing beam, column, and by these kind of components. Any component, it can be beams, it can be columns, it can be wall panels, it can be slab floors, it can be staircase. So replacing your infill walls, beam, column, slab by these precast elements which are customized and made in the factory. Okay, so these are customized factory made beam columns, and then you just assemble them at the site. And joints, you can ask several questions on joints. So there are different kinds of joint. You can have cold joint, you have wet joint, and these joints are emulative joints, so you can ensure monolithic action between the joints. So, you can design the joints like that. So in situ concreting you can do and create a monolithic joint on between these precast elements. Okay, so again, these are the elements. They are L&T. They specialize into precast large concrete panel systems. So you can see the entire facade, the entire outer wall is precast and made in the casting yard, and just hoisted and placed at the desired location, and then connected with other elements. So you can see corner joint, L joint, C joint, this kind of joint with openings, without opening, shear walls, everything is done in the casting yard, and then they are installed. Okay, so this is called precast large concrete panel system. Structural system comprising of various precast elements as walls, beams, slabs, and they can be precast reinforced concrete elements, or it can be pre-stressed also. So if the requirement, heavy load requirement, then you can pre-stress it so that you have a thin section. So, and you can do it at a precasting yard, or you can do it in a factory and then bring it to the site. Okay, and then precast elements are installed at the site with the temporary jacks and shims. Then they are being aligned, and then you can do the in situ concrete at the site. Okay, you can see this. So any element you name, you see staircase. This is the pod element I was talking about. So this is the entire pod element, a toilet block, bath block, or any other you can make, and then just put it. This is a solid slab, hollow core slab. You can have parapet, spindle beam, wall panels, any element you name, you can make and then erect. Okay, this is one of the project by Shirke. There are L&T and Shirke are the two leading companies in our country who are into precast concrete construction. And as I told you, this is again EWS housing for DDA by BG Shirke in Delhi. So this is the picture from Dwarka. So where they have created this kind of high-rise structure using this precast 2D precast. So what they have done, they have made beam, column, and shear walls in the casting yard, and then they have just erected like this. Okay, and all the connection and jointing of various structures are accomplished through in situ concreting. So it is again, they call it 3S, industrialized 3S system. It is their patented system. So they erect beam, column, and slab, partially precast slab, and then they do the in situ concrete, so as to ensure monolithic, continuous, resilient, ductile behavior, monolithic concrete action. Okay. So this is a factory setup, and I will strongly recommend, if you are from Delhi, you should go and visit the casting yard of any precast factory. You go and visit the casting yard. All kinds of sophistication. You will not believe you don't need to cut the bars and all. There are machines, automatic machines are available, and you have to just feed in the computer the size of reinforcement cage, and then you have a reinforcement coil. It will automatically cut the reinforcement, and then make the cage for you. Then you have a concrete, long concrete beds where automated concrete will come, reinforcement cage will be lowered, then you will cast, and then you will cut those, and you will do the pressurized curing, so that they achieve the strength within no time. Within 2 to 3 days the element is ready, and then transported to the site. So all kinds of sophistication has gone into the concrete construction. This is a typical setup from their factory of VG Shirke. And as I told you, you can have hollow core panels also. There are few companies who are making hollow core non-load bearing panels as well. So for infill walls, these panels could be quite good, because being hollow core, they give you a better insulation. Okay. Then there is another company who is making this hollow core panel, non-load bearing panels. Then another precast concrete company, again Gujarat-based, Urbanac, they are making. So most of these precast companies, they give you a total solutions. Okay, so this is normally a EPC contract is being given, and they will do the design. As I remember, I told you DFMA. So they will design for you. They will cast the elements for you, and then they will do the design, erect it for you, and make the building for you, including design and all. So another variant is hollow core, because sometimes if you want to make the entire wall, it may become very heavy. So you can have a heavy hollow. You can make it hollow. You can pre-stress it as well. Okay. You can see this is pre-stressed hollow core column. So you can see this. So any element you can make like this. There was another company, a USA based company, Katera. They have set up a plant in Krishnagiri, which is in the outskirts of Chennai. It's in the border of Bangalore and Tamil Nadu. They have a setup where they are making all these kinds of concrete elements. Then one of the largest project, as I told you, that this can be of different combinations. You can have hollow core wall panel, you can have hollow core slab, or you can have a solid wall as per your requirement and design. Okay, so this is the project under Pradhan Mantri Awas Yojana in Naya Raipur. Okay, in Naya Raipur is in Chhattisgarh, where we have done a PMAY project, okay, one of the largest projects with precast. So what we did, we used precast large panels. So these wall elements are precast large panels, and for slabs we use hollow core slabs. So those were, there was a casting yard was set up there, and these hollow core slabs and large panels were cast there, and then this building was erected. I think the building has already been inaugurated and it is put to use. Then this is the last category, which is 3D precast. So this is another notch above. So here, instead of making these walls separately and this thing, the entire module is made. And again, believe me, this is again this is from the project site of Tata Boisar, for Tata project in Boisar, which is in the outskirts of Mumbai. There is a company called Home Mission, which I was telling you. They have recently made use of this technology in Goa International Airport. So this is that project site of Tata They started with Tata projects and they have made this, and the same person will be delivering a lecture to you. So you can see this is a 4-story structure, and I think 36 units they made in 45 days. Okay. There is another company from Team H from Tamil Nadu who are into this precast concrete construction. Okay, so customized factory-made volumetric construction, entire module is made. You can see this. This is a picture from Bangalore. There is a company in Bangalore, Modocast, who are doing this kind of work. So you can see. So this you can see this. This is a pre-finished with finished. So this is a door and with door and windows pre-finished the entire, and this is a sloping roof. So entire thing is being put over the here to create the upper story. Okay, I'm not going into the details because this will be discussed with you. Okay, so again, this is a picture from his presentation only. So you have a molds you have, then in those molds you insert the reinforcement cage, then pour the concrete, and next day you remove this mold, and then remove the entire module, and then entire module is cured and then put on the trailer, and then brought to the site, and then put one over the other to create the building. Okay, and as I've been telling you now, the last part of my presentation, all these technologies which I talk to you, we have certified these technologies. And why we have certified? Because all of you know, whenever innovative technology or innovative material comes to the market, we are as engineers and architects, we are reluctant. Being in government, sometimes we are reluctant because for the want of certification and a sense of specification standards. So BMTPC has been authorized by Government of India through Gazette notification that to foster innovative products and technologies in the construction sector. BMTPC is authorized to evaluate, assess, and certify new technologies. So all these technologies which I discussed with you or explained to you or have already been certified by BMTPC. There are 42 of them which we have certified, and I just explained you all these technologies. Their certificate, if you want to download, you can go to my website, or on your dashboard we have given a link. So suppose 3D volumetric printing technology you want to see, you just click on that PACS. We call it Performance Appraisal Certification Scheme. In short, it is called PACS. So you can see the certificate. It's a detailed certificate, and we call this detailed certificate as a pre-standard. Okay, so technologies for which there is no standard, this PACS can be used as a standard, and it gives details of the technology, its quality control measures, its construction manual, its user manual, its design methodology, its engineering and other parameters. So the entire certificate gives whole lot of information along with the design details and other details. Okay, so if you're interested in any of these technologies, you can go to that PACS on your dashboard, click that, and you can click on any of the technologies and download the certificate. Okay, then last part is this all technologies which I explained you, it all started, Ministry of Housing and Urban Affairs. We organized in 2019. To be specific, on 2nd and 3rd March 2019, we organized the Global Housing Technology Challenge. It was inaugurated by Honorable Prime Minister, and that time what we did, we threw a challenge to the global players across the world that please show us your construction systems which can help build maximum number of houses in minimum time and minimum cost. So challenge was to the technology providers or the agencies world over that please showcase your construction systems which can help build maximum number of houses in minimum time and minimum cost. So the challenge was a big success. Around more than 80 companies participated, and 54 new technologies were shortlisted. And for shortlisting their technologies, high-level expert group was constituted, which we called technology, TEC, Technology Evaluation Committee, which was headed by DG of CPWD, and we shortlisted these technologies. And the entire details are available on this GSTC website, or on your dashboard. The link is given, and these are those 54. And again, as you can see, I just explained you these categories. These are the categories, 6 categories: stay in place formwork system, So we call it, I just explained you as engineered formwork. This here we have written as monolithic concrete construction. Then sandwich panel system, light gauge and steel structural system. Then precast we have divided into two categories. One is 3D and another one is 2D. And so in each category we had 4, 8, 16, 9. So this all, if you sum it up, we have 54 new technologies. So there is a compendium of these technologies which you can download from your dashboard. We have created a compendium which gives details of the technology providers or agencies who are dealing with these technologies. And these are the technologies which will be explained to you in days to come, each category one day. Okay. And just to promote these technologies, and we are doing 6 lighthouse projects. Okay. And each of these projects is using these 6 distinct category. Like in Indore, we are using sandwich panel system. Rajkot, we are using tunnel form. Chennai, we have used the Chirke technology, precast. Then in Ranchi, we are using 3D volumetric construction. And the person who is executing this project, the agency, he will be delivering the lecture on 3D precast. Then Agartala, we are using light gauge and steel hybrid system. Okay, in Lucknow, we are using PVC wall form. And we are calling them lighthouse projects. And remember, I showed you in the beginning one slide where Honorable Prime Minister was launching our course, this NAVARITIH. So this course was launched during the inaugural foundation stone laying ceremony of all these 6 lighthouse projects. And all of you are being encouraged, and I'll strongly recommend you can go and see these projects. So these projects started in 2021, and despite of COVID, we have already finished Chennai and Rajkot project. These 2 projects have already been completed and handed over to the beneficiaries. In fact, these projects were inaugurated by Honorable Prime Minister and handed over to the beneficiaries. Already beneficiaries are living in these 2 projects, and very soon we'll be completing this Indore and Lucknow and Ranchi project as well. So these are lighthouse projects. Specifically they are called lighthouse means they will show they will guide the construction sector to adopt these technologies for their future projects. Okay, so I will just this is just a slide to show you that these are the 4 companies which were shortlisted under 3D volumetric, then 8 companies under 2D precast concrete construction, then for light gauge and steel 16 companies. All these details are given in that compendium, so you can download that compendium from your dashboard. Then that light drywall construction 9 companies, and these are the names. I just explained you all these. Birdhouse, remember, Bhargav, Rising Japan, Bow Panel, Bird Shell, Questro. Yes, all these companies. Then for formwork system, these are the companies which were shortlisted. Autinod is the tunnel formwork company from Switzerland and French technology, and they are the ones who are doing that Rajkot project. Then stay in place formwork, again 8 companies. You remember I gave you Coffer, Novel Assembler, Reliable and Super. Kaljan. So these are the companies who were shortlisted, and we are doing this Novel Assembler project in Lucknow. This is that slide. So Honorable Prime Minister laid the foundation stone for all these 6 lighthouse projects, and during inauguration, he asked that all the stakeholders associated with the construction sector, primarily academicians, professors, scientists, professionals, students of architecture and engineering, they must visit these lighthouse projects and learn. They should go spend time there, conduct study tours, and see themselves the actual field level implementation of these new innovative technologies for the first time in our country at such a large scale. And each of these lighthouse projects, as I showed you, 1,000+ houses are being constructed in different configurations. Okay, I think I have a slide for each lighthouse project. I'll show you. Yes, so this is the Chennai project. So you see, it's a 6-story structure, 1152 number of houses are being made. So what this project was done by Shirke. So they set up a plant just around 800 meters away from the site. So at the casting yard, they made all elements, beam, column, all these elements were made, then transported to the site, and they created this structure. This is already over and inaugurated. You can see here. So these are the stages. This is a manufacturing plant where you have a molds and then casting yard, pressurized casting yard, where you can do the fast curing. Then these components are made and then transported to the site and erected at the site. You can see, you can erect these components, then you can place the slab, and then you do the in situ concrete to create a monolithic concrete action. And then in between, here they have used infill walls. In Delhi, they are using precast shear walls. So they have, instead of infill walls, you can use precast walls as well. So these are the things they have used. Okay, and in between you can put the services. Okay, this was Chennai. Then in Rajkot, as I told you, again this project is 14-story structure, 11 blocks. Okay, and 114 units. So here we have used this tunnel form. I will show you. Yeah, so this is the tunnel form which is made in the factory, and then this brought to the site, and then you create this kind of tunnels, this kind of thing, and then you do the concreting with slab and all these things, and then erect this kind of structure. So entire one tower was erected in 45 days, and each floor, has around 8 units of 30 square meter. Okay, so tunnel form work from the factory, then these are tunnel forms are erected, and then on the already laid reinforcement cage, and then concreting is done, and then tunnel form is removed, and then infill walls of AEC block is being done. Okay. So Indore, again, I explained you stay in place formwork system we are using. This is that, remember that rising EPS cement wall panel we are using. So again, this is a high rise structures S+8, and this wall panel is a non-load bearing wall panel. So we are using steel sections for beam and columns. Okay, so these are built up sections, pre-engineered steel sections are being used for beam and columns, and then for floors we are using deck slab. Okay, so this is a composite slab. So you have a profile sheet. Over that you put a nominal reinforcement and do the concrete. You can see here. So concreting is done, and you can put all services and all. And this, you can see this white thing. This is that Rising Japan EPS panel, sandwich panel system with calcium silicate board as facing sheets, and in between you have a lightweight elevated concrete. Okay, then in Lucknow, this project again 14-story structure. So again, same hybrid construction we are using, and here we are using PVC wall forms. Remember, I told you stay in place form, pre-finished walls. So these are those again built up sections of steel and column, deck, slab, and then these are the pre-finished walls as infill walls, and in between they are filled with concrete. Okay. So this is what is being used in Lucknow. Agartala, again, hybrid structure, and these walls are of light gauge steel. Okay, I will show you. Again, it is a G+6, 7-story structure. So it's a hybrid construction. Again, steel structure with the deck composite slab, and we have this, what you can see in on second. This is the light gauge panels. So these are light gauge panels. Panels, wall panels are made with light gauge, and both sides we are putting precast concrete panel, and the cavity is filled with lightweight concrete here. And this is that Ranchi, very interesting project you can see here. Again, we will have a detailed presentation on this. And this is again, these modules, I will show you. Yeah, you can see this is a casting yard, which is just, which is just made adjacent to the site. In a casting yard, all these modules are being made and then put one over the other to create the entire building. You can see here. So already the entire, it's a 9-story structure. So already most of the blocks have reached up to 9-story. So you all can go and visit these projects. So these are these lighthouse projects. And this is a slide I wanted to show you, that while inaugurating these projects, Honorable Prime Minister said that these projects are the pilot projects, and our engineers, planners, students should go study these projects, learn about the technologies, and then later they can adopt these technologies as a future project. So we are using these projects as live laboratories. So all of you can go and visit these projects. And on your dashboard, we have provided a link of Technograhi. So you can just register yourself free of cost as Technograhi, and once you become a Technograhi, you can just go to the project site and visit these projects. And Technograhi also, we have created the modules, e-learning modules for Technograhis, and where those modules are created by me only. So you will find presentations in my voice, so you can go through those presentations on each of these categories, and on these lighthouse, specifically on those lighthouse projects, and visit these projects whenever you want to. Okay, and because there are teams stationed at project sites, so you can just go there and spend some time, 1 day, 2 day, or as per your availability, and see yourself those projects. Okay, and as I was telling you, we are not stopping there. We are also demonstrating these technologies through demonstration housing projects across the country. We have already completed these projects, and these are the live projects which are going on. So Ahmedabad project is already over. So if you live in nearby area, you can go and visit these projects. Every project we are using a new technology. Here, Ayodhya, we are using light gauge. Guwahati, we are using light gauge. Bhopal, we have used that stay place formwork. Here, we have used sandwich panel system. Tirupur, we are using precast concrete construction. Dimapur, we are using that sandwich panel system. So each project is with a different technology, and around 40 houses we are constructing. And during the construction time, we also impart training to professionals, students, as well as artisans, so as to spread the awareness and to educate the masses. And as I have been telling you that it's to popularize, to mainstream these technologies, it is very important that we create a enabling ecosystem for these technologies. So we are working hand in hand with the CPWD. CPWD has already issued SOR, schedule of rate, for all these technologies. I think we have given a link on our website. So for all these technologies, they have a SOR, like we have Delhi schedule of rates. Similarly, they have created Delhi schedule of rates for new emerging technologies. So you can download that. I think we have put that PDF file for you on your dashboard as well. So you can download and see the schedule of rate for all these technologies. Also, in nowadays, because of time and because of the advantages associated with these technologies, most of these states, like in Andhra Pradesh is one of the biggest state who is using this monolithic aluminum formwork system, tunnel formwork. Hyderabad, a lot of agencies are using that tunnel form and precast. For Chennai, they are using Tamil Nadu, they are using precast concrete construction and tunnel form. So as per your requirement, you can use any of the technologies. One more thing I wanted to tell you here, that this is a basket of 54 technologies, and as per suiting to your requirements, suiting to your time and finances available, you can choose any of the technologies. So as I often say, we have created a basket of 54 innovative, alternate, sustainable technologies, and as per your requirements, as per your space, other things, as per the agencies available, you can choose any one of the technology. Okay, so with this, we come to the end of this today's lecture, this 3-hour lecture. And so today, what I have done is I have given you brief overview of what Ministry of Housing and Urban Affairs, BMTPC, has done. So what we have done, we have created a basket. We have been studying these technologies, and we are trying to, promote these technologies through these initiatives. Also, when this GHTC was Global Housing Technology Challenge was organized, that time itself, Honorable Prime Minister desired that we should, at least educate people, educate professionals regarding these technologies, because we know that still people do not know about these technologies, and most of us know about these technologies, but these technologies do exist in our country is not known. So through these courses, we are trying to reach out to all of you professionals, trying to teach you, trying to educate you, trying to make you aware about these technologies, so that in your future projects you can use these technologies. Also, you can visit these projects, all of these projects which are ongoing, and understand yourself the various intricacy of these technologies. Also, the agencies who are into these technologies can be reached. You can connect with them, their addresses, their numbers, everything is being given in the compendiums. Constantly, we are publishing literature on all these technologies. So you can get access to all these technology providers and start exploring these technologies. Also, we have provided enough literature on your dashboard. So please, because through these lectures are for 1 hour or so, or 3 hours. Through that, referring to that literature, because it's a new literature, and you will find these literatures in scattered form in different books and all. So we have put them in a single book, compact form in that book, which is being given to you, so you can refer and start using these technologies. So with this, I come to the end of today's lecture. Thank you very much. And as I told you, that every day we will have lectures on 5:30 to 8 o'clock each day. One category will be discussed, but on Saturday, Sunday, we will have lectures from 2 to 5. Okay, so tomorrow we are going to discuss GFRG, glass fiber reinforced gypsum, and 3D printing technologies, and those two lectures will be given by professors from IIT. Okay, and every day you can write your questions in the chat box, and if time permits, we will take those questions from the chat box. So since we have already you know already crossed 8:30, so we will end here, and thank you very much for your patient hearing. If you have any questions, you can just write in chat box. I will try to answer them whenever I get time. Otherwise, through email we will try to answer. Anyway, all these questions you can ask from tomorrow onwards when specific lectures on these technologies are being given to you. So thank you very much for your patient hearing, and let's meet again tomorrow at 2 o'clock. Thank you very much.